So hi, today we are going to see Nifty minute level stock price data prediction using long short-term memory neural network long short-term memory. So this is I have already created a code for this. I have already have data of Nifty minute level data. So for that, what I will do, I will copy this link. This I will share in the description box. I will copy these links and I will open a new tab and I will paste this link here and it will open this. Now what I will do, I will click here on code. I will click here on code and I will click here on drop down, this drop down, or I can click on code. Uh, this is the GitHub account. This is the GitHub account. When you will open this with this link, when you will open this with this link by copy pasting, this will open the GitHub. What you will do, you will go to here and you will click on this G83 here link for Kaggle. You will click on this. Wait, it will open. Double click on that link for Kaggle and it will give. We will click on view raw. You will double click on view raw. It will download. Now you will open this here. Open this file that we have downloaded from GitHub. You will open this file. First of all, save this file. GitHub link to download Kaggle Notebook link. We'll save it here. Now that link is opened. Now what is Nifty? Real minute level data trained on long short term memory, precise accurate model created for prediction of Nifty stock prices. Link Nifty, Kaggle LSTM. This is the link. We will copy this link. First of all, enable editing. We will copy this link. We will copy this link. Right click, copy. We will go here. We will open a window. We will paste that link here. Control V paste. This we can do. We will copy paste this link here. It will open the Kaggle notebook. Now this is Kaggle. This is notebook 390CEVV9. What we'll do, we'll click here on copy and edit. I will share. This is here now. Now when you click on copy and edit, this will give the code that I have written previously. Now I can see the code, all code here. You can see it is giving the accuracy of, it is R2 score. This is giving the accuracy of 0.998639, 99.86%. It is giving the accuracy R2 score of the fitting of the model. So here we can see this code you will get written beforehand. It will be written automatically when you will open this code. This code comes written from before, or this code comes already written when you download this Nifty data. Now what we can do, we run this code. We'll click here and we will click here to run current cell. It will run. The code we say downloading copy of notebook to avoid refresh. Reload. We will click here to run. Here we will click to run this thing here. We run it. Why this is not running? Let's click here, run all. First let's sign in. Okay, sign in. Sign in with Google. I'm choosing this account. You can choose any Google account. I'm choosing this. You can choose your Google account. And next. Next. Try another way. Sign in with Google. I'm choosing this. Continue. Next. We will click this here. We will copy and edit notebook. We will sign in with the account. We sign in with Google. First of all, sign in with Google. Then we sign in with this account. It is signed in now. The sign in is successful. Now we have signed into the Kaggle notebook, kaggle.com. Now we run this cell. Session is starting. Written here. Nifty preparing to download. It is downloading this Nifty 50-minute data. This is the data that we will work on. It is 816 MB size in the data. The data on which we are working, its size is 816 MB. So let's check how many rows are and how many columns and rows are there in this data. For that, what we will do? First of all, we have downloaded. This cell is running now. It is running in progress. It is reading the file names. So we get these are all the data file names. These are all the tables, data names, location of the data. So we are interested in this data, this 50-minute data, where it is. We are interested in this data, Nifty 50-minute level data. We are interested in this location. So we read the file at this location. This is the location on the cloud on the Kaggle server. This is the location. And from this location we read this file name nifty 50minute.csv. It is CSV file. So we run this cell to read the data. Why it is not running? It is giving error. Parse.dates is equal to true. Let's copy this. It is telling no such file. Let's copy this. Copy this location. Copy this location path. Let's copy this path and paste it here. Paste it here between single quotes. Now run it. I think the cell has executed successfully. Now let's check the how many rows and how many columns are there in this data. Let's run this. This data has 9,75,321 rows and 6 columns. Let's see the column names of this data. Nifty.info. This data has these 6 columns: date, open price, high price, low price, close price, volume. So this is the date. On this date, what was the opening price when the stock has started in the market on this very date? What was its opening price? Then what was on this date, on this single date, what was the highest price the stock has reached, and what was the lowest price the stock has reached? And at the end of the day, when market has closed off, when share market Nifty 50 has closed at the end of the day, what was its closing price? And this was volume. What was the volume? Volume has, how many volume was traded on this day? You can ignore this volume for now. We are interested in these closing price, low price, high price, open price, and date. So here we can see Nifty. When we run this, we see the data. So this is the data that we have. Date we have, opening price, high price, low price, close volume. That so on 9 September 2015, the opening price was 8,285 rupees 45 paisa, and close price was 8,292 rupees 0.1 paisa. So this was all the price from 0th row to 9,75,320 20th row. We have these are the rows and 6 columns like this we have. So after that, what we do? Nifty date PD.to date time. So here this date column here is in text format. We need to convert this to first date format. So for that we run this code. We run this code. This code has run. Now we see this data. Now we see the info. Now this is in date time format. See, this date column data type is date time, but previously the data type was object. Object data type is text data type, string. Text data type, it is in text form. We cannot infer as it, the computer will not know which date it is. But now it is in date time format. This date column is now in date time format, so computer can know which date it was. Now it can know computer. So now we run this cell. This cell we run to drop the volume. We don't need this volume column, so we drop this volume column by running this cell. It is executed. Now let's see how is data now. Now our data has date column, open price, high price, low price, and close price. Volume column is dropped. Now we read these 2 libraries for analysis purpose. Now from this we normalize. Now we will normalize min-max scalar. This is a data science technique. Min-max scalar. Now you can ignore this for now. We run this code. Now we are preparing. We are processing this data now with these codes. We are processing data. Now let's see x dot shape this and y dot shape this. We process this data. Now we have chosen training size to be 80%. With this, what does this mean? I am telling computer that training size will be 80%. From the 100%, 80% will be training size and test size. That it means that we will train our AI model on 80% of the data, and we will test it on the 20% of the data. So train test in AI means, suppose we have 1 lakh rows. 1 lakh rows in the time series from 1 September 2023 to 1 September 2025. We have data from this range. So we have total 1 lakh rows. So what I will do, whenever I will create a machine learning or AI model for prediction of price or for classification, for any type of prediction in AI, we will first create our model. We will define the model parameters. We will choose some good model, some definite working model. For that, a suitable model for that, we will choose it by our analysis. Once the model is chosen, what we do, we pick up 80% or 75% or 60% of data from our 1 lakh row of data. We pick up nearly 60,000, 70,000, 80,000, or any number of rows, but it should be less than 80%. greater than 60% and less than 80% is the optimal one, good one. We should choose, we not must, but we should choose between 60 to 80% to the train size. We pick up from 1 lakh rows, we pick up 60,000, 70,000 or 80,000 rows of, let's say we pick up 80,000 rows of data from 1 lakh row of total data. From 1 lakh row of total data, we pick up 80,000 rows of data of starting from 1 September to between, we from starting in continuous manner. We pick up 80% of data like 80,000 rows, and now we will apply this AI model. We will apply this AI model, like we will run the code of this AI model on these 80,000 rows of data. Now what will AI model do? It will run, it will take 5 minutes, 10 minutes or 2 minutes, 1 minute or even half an hour or even 1 hour or even 1 day. If model is very large or data is very huge, it may take 1 month also to be trained. But if a computer configuration is too low and data is in, let's say, 1 terabyte, 1 petabyte, then it will take very too much time. So for that, supercomputers or quantum computers or high configuration computer come for high size of data. But here we have only 10 lakh, not more than 10 lakh of data, but it will take it will train instantly. So no worry, don't worry about that. It will not take time in this for training. So we train that data on this 80,000 of rows. So what it will do, it will train automatically when we write the code, and it will update some weights, some biases. It will have 1 lakh, 10 lakh or 20 lakhs of neurons in it, and every neuron will in that neural network in a LSTM, long short term memory AI model. Every neuron will have its weight and biases. It will omit old weights and biases and update new weight and biases. It will keep on updating biases and weights. Biases and weights are the numbers of the neuron equation. It will keep on updating, and it will do unless we have the very good predictable score. It will update weights and biases of the neuron. Weights and biases are nothing, these are numbers. It will change and update them until and unless we have the good score like 90% above, 90% or 98%, 95% score of predictability. Unless we have this score, so what we do here, we have train sizes. We split our data, or we split our data of 9,67,000 rows of data. We split into 80% for training. So this is how we train our data on training size 80,000 of rows. Suppose we have 1 lakh row of data. Here the data we have is of 9,75,000 rows. But in case, let's assume we have 1 lakh rows of data. So on 80,000 rows of data, we train the model, and once model is trained, then we will predict on the left 20,000 rows of data. And if the prediction has the good score, like suppose 95%, 98%, 90% or 70%, 80%, then we assume, then we say that model has predicted well and the data is quite predictable. Price is quite predictable, or anything we are predicting is quite predictable for that data. So here we split the data into 80% and we apply this code. Let's run this. Here we have the total data rows of 9,75,000, something like that nearly. So we split 80% of data to training and 20% for validation or verification or for prediction or for checking our score, how good our model is predicting. So what we happen with computer does not know. Computer only knows the training data. Computer has trained on the training data. AI model has trained on the training data. It does not know anything about the test data, or that 20% data. It does not know anything about it. Computer does not know about anything about the 20% data, the testing data. Computer does not know anything about the testing data. It only knows about the 80% training data. So when computer is predicting on testing data, it does not know which data is that in 20,000 rows, or in that 20% of data, what data is there. It will predict something which is quite near to the original amount of the original actual data that we have 20%. So what we will do, we will create for that 20% data, we will we will feed the we will feed date, we will feed only dates. First we train on this is very important, please listen. First we will train on 80% of data, all columns, all rows we train, okay. After that, we only give the 20% data. Suppose 1 lakh data is there. Let's assume 1 lakh data of rows is there. On 80,000 data, all columns we have trained. 5, 6 columns we have. All columns we have trained on that, and model is ready. Now what we will do? We have 20,000 rows of data. From that 20,000 rows of data, we will omit all the columns. We will not consider all columns. We will take only date columns. For 20,000 rows of data, we will take 20,000 continuous dates. Now we will put those 20,000 continuous dates of data in that are ready trained model. When we put that the 20,000 dates of data in a trained model, it will give some price value like opening, low, high, close price values. For the according to them our trained model, it will predict some price values. Now what we have, we have the predicted prices for the four columns: low, high, and close, and open. We have the predicted prices. Now we will, from those predicted prices, we will subtract the actual price that we have, original price, this one. When we read this data, we have actual data is this. So let's say we put 20,000 dates from here in the trained model, and it predict these four columns. It does not know what are these values. It does not know what are these four values. It will predict something around near these values. Now let's say we have predicted data. Let's say we have the here predicted data. This is actual data. Now predicted data, we have all the 5 columns, date and their predicted prices. So from those predicted prices, we will subtract these actual prices, and we will have some value. That value is known as error. What is the error in the prediction? Is the difference between predicted values and the actual values, actual prices. So that is the error. So according to, we need to minimize that error. The extent we minimize that error, the good will be our model. The good predictability will be of our data or model. If data is predictable, then its error will be low. Difference will be, subtraction difference will be low between the difference between a predicted price and actual price will be low. Total they, like suppose we predicted open price is, let's say, 8290.16. Let's say predicted price is 8290 and open price is 8285. So difference is 8290 minus 8285, 5 plus 5 is the error. Let's say here 8295 is the high price, actual one, and 8290 is the predicted price. So here difference is -5. So -5 will be our error here. So what we will do, we will subtract all these single values of all these values. We will subtract this from predicted, this from predicted, this from predicted. We subtract all these values in all these data values, and we will sum those errors. After summing those errors, we have the sum of errors, total sum of errors. So we need to minimize that total sum of error. That is known as mean absolute error. We call it mean absolute error. No, we can call it absolute error. But when we take those errors average, it is known as mean absolute error. When we take the absolute errors average. Absolute error, why we call it absolute error? Because here we get the +5 difference. I'm telling example, the difference can be anything in decimals. Suppose we have here 5, here we have -5, but we will not consider -5. We will consider the positive sign. Even if the error is negative, we will convert it to positive. Suppose error has come, the predicted low price and actual low price at this date. The error is suppose -1.41. So we will take 1.41 because we need to sum those absolute errors. We will not consider negative signs. So after summing those errors, so it is definitely, you can understand here from here, the larger the sum of errors, absolute errors, the larger the sum of absolute errors, positive errors, the larger will be the lower will be the quality of our model, or lower will be the predictability of our data set. So the error should be very low. Error should be very low. The lower will be error, the good will be predictability of the prices. So like here we have done here, we have run the data till here. Now what we will do, we have run this already. We have run this code already. The data is split into 80% train size and 20% test size. So on train size, we have now we have the train data. This is the train data. In this data we have four columns. Now in this data we have let's say we have to split data into X is for the data that we will train a model on, and Y is let's see, I'm running it here. Let's run it. So we have here, we have in training set data set we have 7,80,248 columns, and in test data set we have 1,95,661 columns. Oh, sorry, not columns, rows. In trained data set we have 7,80,248 rows of data and 4 columns of data, and in test data we have 1,95,061 rows of data and 4 columns of data. Total we have 9,75,309 9,70,309 of what we say rows of data total we have, and 4 columns total we have. So let's see this data visually. Let's add one cell above it. Here we write X train. So in training data set what we have these 4 columns. This is known as we have these 4 columns. This date is stationary. This date we have, this date is as the index. This date is index, and these are 4 columns. Date is known as index here. So we have all this. This is known as this column is low open price. This column is high price. This column is low price. This column is close price. We have all the 4 columns, and it is continuously moving forward with the dates which are indexed. So we have these 4 columns here in X train. Similarly, we have in X test we have training data. We have 4 columns, and in 4 columns training data we have 4 columns and 7,80,248 rows. Here we can see, and in let's say test data we have this is the test data. In test data we have 1,95,061 1,95,061 rows and 4 columns. These are 4 columns. This column is open, this column is high price, this column is low price, this column is close price. So first we have seen these X test and X train. First I showed you X train, now I showed you X test. Now let's see Y train. Now X test and X train is a complete data that we have fed by splitting into rows 80%, 20%. Now what is Y train and Y test? That I am showing you now. Y train is, this is Y train. In Y train also we have these. In Y train also we have the same number of rows as in the X train. See, this X train and Y train have the same rows and same columns. Why we need Y train? Because from Y train we will calculate the error in predictability. Whatever will be the difference between X train and Y train, that will be the error in the predictability. The difference will be error in the predictability. From that we will calculate our score. So here is now I am showing you X test. One thing I want to tell you that we will calculate the score of predictability between X train and Y train. Train will have one predictability score. The score between X train and Y train will be the score that first of all we train whatever the thing that happens here. First we train data on a training data set. First we train the data on X train. This data we train on this data. These are the rows. This is first rows and this last is column. We train on the model on this data. Then we calculate the score. Then we calculate these 4 columns difference from these Y train. Let's first of all, what we have done, we have split it. Now I'm telling from starting what we have done here. We have splitted the data. First of all, we have data, one single data. We split those that data into two parts. Training data, here it is training and testing. In training we have two categories, x and y, and in testing also we have two categories, x and y. So what the thing will happen here, when we will calculate the score of predictability, training data set will have different predictability score, and testing data will have different predictability score. And one thing I want to tell here, the training data score will be very near to 100%. It will be very near to 100% because we have trained on training data. The model is trained on training data. The model is trained on X train, and we calculate the score from Y train. So the computer, the machine learning model, the AI model already knows what data will be. So it will be quite a low error, very high predictability for training data because computer has already trained on that data. I'm explaining it with an example. First I have given a data to computer. The computer has read all the data. Now I'm telling computer calculate the score of predictability. The computer already knows the data for training data set. So it will predict a good score. But what in case of testing data set? In testing data set, computer does not know what is in the X test and what is in the Y test. It does not know. So what we in testing data set, computer will be given first computer the score. We I think we do not need X test here. We can delete this X test. X test we can. One thing is here first we X train, Y train. From yes, first we trained the model on X train, then we calculated the predictability score from Y train by subtracting the values. After that, we predict the X test data from our model. The model that we have trained on X train, we will predict using that model. We will put X test values in that model, and it will predict some values. So from that value, we will. So we don't X test will be predicted. Okay, so we don't need here Y test. We don't need here Y test. Y test we don't need. We don't need only these three: X train, Y train, and X test. Now what will happen? With the data is in two categories: train data, training size on which model will be trained. 80% will be training set and 20% will be test data. 80% will be trained data. First of all, we train the model on this X train data. On this data, this much rows and this much columns. This 12 you can ignore. We calculate training on this data, then we calculate the difference between this rows and this data, this y data. We calculate the difference, and whatever is the difference, if the difference is quite low, then there will be good predictability of prices. After that, we put these X test values in this model. We don't put, we tell the computer that predict for this 20% data. We tell computer that you do not know this 20% data, now predict the prices for this 20% data. So what it will do, it will predict some prices for 20% data, and we will calculate the score from that. And that will be our original score. From the testing data, the score we have, that will be our original score, because computer does not know test data, because computer was trained on this trained data, and it does not know what is in X test data. It was not trained on that. So that will be our score in test data. Whatever will become, that will be our original score for predictability. So here we have this is TensorFlow is the library, TensorFlow.keras. This is the AI library in Python for LSTM. We have import LSTM here. TensorFlow keras layers, we have import LSTM model. The sequential dense. We run it here. It will take some time, nearly 30 to 40 seconds. It has run successfully. Now our model is this. Now we compile this model. What is here is I have used this in we have created this long short-term memory model from the AI library TensorFlow. This LSTM long short-term memory model I will give 100 neurons for with activation function of 10h and return sequences input shape will be 12. So what I'm using, I'm creating here three layers of neuron. One layer will have 100 neurons, second layer will have 100 neurons, this is middle layer, and last layer will have 4 neurons. Why I have chosen here 4 neurons at last layer? Because we have 4 columns of data, we want to predict 4 columns. If I want to predict only one column, I have given here 1. If I want to predict 2 columns, I cannot give here 5, because I have maximum I have 4 columns in my data set. So I will give here 4 only, or less than 4 but greater than equal to 1. So I run this. Now this is done. Now we fit X train and Y train. We tell the computer that this is the X train data, this is the Y data, this is the 80% of data, this is the 20% of data. No, not sorry, this is the 80% of data, this also is 80% of data. We fit the data, we fit this, now we fit these X and Y, they fit this training data. 80% of training data, these two we fit here. Now we train this model by on this 80% data. X train and Y train are the 80% data. We now train on this data. Now we train our model on this data. We run this. It will train on 80% of data. It is training. The training process is happening. It now what it is doing. It is update. Now what it is doing. It is updating the weights and biases of these neurons. These neurons are entered neurons at the starting middle level, middle layer 100 neurons, and last layer 4 neurons. So it is updating weights and biases for these 3 layers of neurons. 100 neurons, these 100 neurons starting at the first layer, these 100 neurons weights and biases will be updated. This 100 at first layer there will be 100 weights and 100 biases. So it will update those weights and biases and gates. Some gates also it will also update, because this is LSTM model. So it will update some type of gates, some type of weights, some type of biases. These all are the mathematical numbers in decimals. Then in second layer it will also update some weights, biases and gates numbers. Then at the last layer also it will update, and that value will be our predicted value. It has done it is training model. The model is training. The training is happening in model. The model is training on the 80% of data. The training is happening on the 80% of data. Now this is our training data, train data, and this is validation data, X test and Y test. This is validation data, X test and Y test, and this is our training data. 80% data is training, 20% data is test. So what here the thing is happening? It is giving at every epoch it will train the data on 20 times. So at every epoch it is giving some validation loss. Here the validation loss is 1.1232. Here the validation loss has increased, again it has decreased, again it has increased here. And the loss is like this happening. And this is the mean absolute error. The error, the residuals, the difference of the predictable and actual values. So till now 11 out of 20 epochs are done. I am pausing the video. Let's make it when it will be done 20 out of 20 epochs, then I will move. यहाँ पर अपने epochs complete हो चुके हैं. अब यहाँ पर एक चीज मैं क्लियर करना चाहता हूँ जो मैं बताना भूल गया था. जब मैंने डाटा को प्री प्रोसेस किया था, ये मैं बताना भूल गया था. ये मैं तो मैंने जब डाटा को प्री प्रोसेस किया था, मैंने इससे किया था प्री प्रोसेस. इसमें मैंने क्या किया, मैंने डाटा के 12 टाइम स्टेप्स लिए, 12 कॉलम्स बनाए, मतलब कि 12 टाइम स्टेप्स, और उसका अगला टाइम स्टेप y में डाल दिया। मतलब कि जो एक्सट्रेन होगा 0 टू एंड, मतलब कि मैंने यहाँ पर y की शेप आई थी, यहाँ पर आप देख पा रहे हैं x के अंदर इतनी रोज हैं 9 लाख समथिंग, और 4 कॉलम्स हैं। 4 मतलब कि 4 हमारे पास कॉलम्स हैं, मतलब कि लो प्राइस, ओपन प्राइस, क्लोज प्राइस एंड हाई प्राइस। लेकिन उनके अंदर 12 टाइम स्टेप्स हैं, मतलब कि हर रो के लिए, और हर मतलब कि ऐसा होगा, मतलब कि जैसे ओपन कॉलम है, ओपन कॉलम के पास इतनी रोज होंगी और इतने कॉलम्स होंगे। उसी तरह हाई कॉलम आ गया, यहाँ पे हाई कॉलम के पास इतनी रोज होंगी, इतने कॉलम्स होंगे। ये जो कॉलम्स है 12, हर 4 कॉलम के लिए जो 12 कॉलम है वो है उनके पिछले 12 दिन के। जैसे आज 13 सितंबर है, तो 13 माइनस 12 मतलब कि 1 सितंबर से लेकर 12 सितंबर तक का प्राइस का डाटा, ये 12 कॉलम हो गए। और 13 सितंबर होगा उसका ये वाला वैल्यू, जो उसका ये वैल्यू होगा, मतलब कि हर 4 कॉलम के लिए एक सिंगल रो होगी। मतलब कि मैंने डाटा को ऐसे कर दिया, मैं आपको समझाता हूँ। मान लीजिए कॉलम 1, कॉलम 1, कॉलम 2, कॉलम 3, कॉलम 4, कॉलम 3। अभी हर 4 कॉलम है मेरे पास। इधर डेट जो है ये इंडेक्स है, डेट इंडेक्स है। ये आप नोट कर सकते हो, 4 कॉलम हमारे पास कॉन्टिन्यूस मैनर में डेट से इंक्रीजिंग हो रही है। 1 सितंबर, 2 सितंबर, 3 सितंबर, ऐसे जाके 2025 तक, 2024 तक अपने पास डाटा है जो भी है। और 1 सितंबर 2015 से लेकर आज तक का डाटा है। टोटल हमारे पास मान लीजिए 9 लाख, फॉर एग्जांपल हमारे पास 10 लाख रोज हैं और 4 कॉलम्स हैं। तो मैंने इस डाटा को क्या शेप किया, जैसे मान लीजिए यहाँ पर 1 सितंबर 2015 है, इसको मैं नीचे कर देता हूँ। मान लीजिए नीचे तक, मतलब कि ऐसे एग्जांपल बता रहा हूँ, पूरा डाटा नहीं है इसमें, और भी डेट्स आगे होंगी इसमें, मैंने यही तक लिया एग्जांपल के लिए। अब यहाँ पर कुछ वैल्यूज हैं, ले लेते हैं 8000, 9000, नीचे तक और ले लो। नीचे तक और ले लिया एग्जाम्पल के लिए, जैसे पेस्टेड वैल्यूज कर देंगे। अभी अपने पास डाटा आ गया। अब मैंने क्या किया, मैंने ये 12 दिन का डाटा लिया, 12 दिन का डाटा मैंने लिया इन 4 कॉलम्स का। मैंने इसको ऐसे रीशेप कर दिया, ट्रांसपोज कर दिया उस पाइथन में वहां पर। तो उससे मैंने यहाँ पर इसे किया, उसे यहाँ पर मैंने किया इक्वल टू ट्रांसपोज, ये 12 दिन का डाटा, 12 दिन का स्टार्टिंग के। अब ये ऐसे आ गया। ये अब ये 12 दिन का डाटा ऐसे आ गया। कॉलम 1 का कॉलम 2 इन्हें हम कर देते हैं ओपन लो, ओपन, यहाँ पर जैसे मैंने कर दिया ओपन लो हाई क्लोज, ये मैंने कर दिया। अब ये मतलब कि मेरी एक होगी, ये मेरा एक रिकॉर्ड हो गया मेरा ये। अब ये इसके अंदर मेरे पास 12 कॉलम्स हो गए और ये 4 कॉलम्स ये हो गए, उनके 12 कॉलम्स डेट वैल्यूज हो गई मेरे पास ट्रांसपोज करके। और ये मेरा हो गया एक एक रिकॉर्ड हो गया, ये मेरा पूरा एक रिकॉर्ड हो गया एक्स एक्सिस का। एक्सिस का ही मेरा पूरा मतलब कि एक्स ट्रेन के अंदर मेरा ये पूरा एक्स ट्रेन जो डाटा वापस उसके अंदर मेरा ये पूरा एक रिकॉर्ड हो गया। अब मान लीजिए इसका अगला रिकॉर्ड क्या हो गया एक्स ट्रेन का, एक्स ट्रेन का अगला रिकॉर्ड क्या होगा, अगला रिकॉर्ड होगा एक्स ट्रेन का नहीं, इसका अगला रिकॉर्ड क्या होगा एक्स ट्रेन का। अब ये 1 सितंबर से 12 सितंबर हम ले लिया, अब हम लेंगे 2 सितंबर से 13 सितंबर। ये ट्रांसपोज हमने किया। अब ये अपना आ गया 2 सितंबर से 13 सितंबर। ये अपना आ गया 2 सितंबर से 2 सितंबर से 13 सितंबर। यहाँ पर कर दो। सितंबर से 13 सितंबर और ये अपना आ गया यहाँ पे ये हो गया अपना दूसरा, ये हो गया एक्सट्रेन का पहला रिकॉर्ड, ये हो गया दूसरा रिकॉर्ड। इसी तरह हमारे पास क्या है यहाँ पर एक्सट्रेन के, हमारे पास टोटल यहाँ पर कितने रिकॉर्ड्स हैं 9,75,309। इसी तरह यहाँ पर हमारे पास लास्ट रिकॉर्ड होगा, ये पूरा सेकंड रिकॉर्ड हो गया और ये पूरा फर्स्ट रिकॉर्ड। इसी तरह डेट आगे बढ़ते जाएंगे 3 to 14, 4 to 16, 5 to 17, जैसे यहाँ पर 1 to 12 है, 2 to 13 ऐसे बढ़ते जाएगा। इसी तरह हमारे पास एक्सट्रेन के हो जाएंगे, आखिरी रिकॉर्ड होगा हमारा ये वाला 9,75,309th रिकॉर्ड होगा ये हमारा। और ये होगा हमारा सेकंड, मतलब कि ऐसे मतलब कि बढ़ते जाएंगे, मतलब कि यहाँ तक स्टॉप हो जाएगा। उसी तरह अब क्या होगा, ये तो हमारा 12 दिन का है। पहले रिकॉर्ड का वाई ट्रेन क्या होगा, पहले रिकॉर्ड का वाई ट्रेन होगा जो ये वाली वैल्यू होगी। 1 से 12 था हमारा पहला रिकॉर्ड, तो उसका वाई ट्रेन हो गया ये वाला हो गया हमारा वाई ट्रेन, जैसे इक्वल टू ट्रांसपोज, ये हो गया अपना वाई ट्रेन, ये हो गया हमारा वाई ट्रेन, वाई ट्रेन। जो 13 सितंबर हमारे हो गया वाई ट्रेन, तो इसे हम उठा के यहाँ पर कर देंगे, मतलब कि यह हो गया हमारा वाई ट्रेन। ये हो गया हमारा वाई ट्रेन। तो इतना डाटा हमारा रिकॉर्ड नंबर 1 एक्स ट्रेन का, ये हो गया हमारा वाई ट्रेन का डाटा। तो एक्स ट्रेन वाई ट्रेन ऐसा हो गया, जैसे आपने देखा यहाँ पर साइज हम देखें, एक्स ट्रेन का साइज क्या है, इतनी रोज, इतने टाइम स्टेप्स 12, 1 to 12 और 4 कॉलम्स। यहाँ पर क्या हो गया 4 कॉलम्स और इतने रोज ही हैं सिर्फ, क्योंकि ये 4 कॉलम्स तो जो हैं ये इसका डाटा हो गया, अगले एक ही डेट का, और यहाँ पर 12 डेट का डाटा है इसलिए वहां पर 12 है। तो यहाँ पर एक डेट का डाटा है तो वहां पर 1 ही रहेगा, तो 1 वहां पर लिखा नहीं हुआ उसकी जरूरत नहीं, लेकिन मतलब ये 1 ही रहेगा। और यहाँ पर 4 कॉलम्स रहेंगे, 4 कॉलम्स, और इसी तरह यहाँ पर बाई ट्रेन भी इतनी रोज तक जाएगा। आखिरी डाटा होगा बाई ट्रेन का यहाँ तक, बाई ट्रेन, बाई ट्रेन का डाटा भी यहाँ तक जाएगा सेम। बस उसमें 12 डेट्स नहीं होंगी, एक ही डेट होगी अगली डेट इसके। जैसे यहाँ पर अगली डेट हो जाएगी 14th, यहाँ पर अगली डेट हो जाएगी 14 सितंबर। इसी तरह अगला रिकॉर्ड आएगा एक्सटेंड का, तो थर्ड रिकॉर्ड होगा वो होगा 3 से लेकर 14 तक, और बाई ट्रेन की वैल्यू हो जाएगी वहां पर 15। ऐसे ये चलता जाएगा। तो इस तरह से ये हमारे डाटा को प्री प्रोसेस किया LSTM मॉडल, AI मॉडल में ट्रेन करने के लिए। तो इस तरह से हमारा ये है यहाँ पर। तो अब हमारा डाटा ट्रेन हो चुका है मॉडल। अब वो यहाँ पर तो इपॉक्स, तो लास्ट में हमारे पास जो लॉस आया इतना आया है, मीन एब्सोल्यूट एरर इतना आया है, वैलिडेशन लॉस हमारा ये है। जैसे हमने यहाँ पर देखा कि यहाँ पर क्या हुआ था, हमारा वैलिडेशन लॉस बढ़ना शुरू हो गया और मीन एब्सोल्यूट एरर घटना शुरू हो गया। तो हमारा ना एक तरह से ये सेकंड इपॉक में मॉडल परफेक्ट दे रहा है, हमने फालतू में 20 इपॉक तक कर लिया। इसकी ट्रिक क्या है जानने की, जब भी हमारा वैलिडेशन लॉस कम हो जाए और मीन एब्सोल्यूट एरर, नहीं मीन एब्सोल्यूट एरर, ये जो है मीन एब्सोल्यूट एरर अगले में कम हो जाए, जो कि यहाँ पर 0.0037 था, यहाँ पर 0.0010 के कम हो गया, और यहाँ पर हमारा वैलिडेशन लॉस क्या था 1.12, यहाँ पर 8.27 बढ़ गया। तो इसका मतलब कि जो फर्स्ट इपॉक पे जो मॉडल ट्रेन होके आया था वो सबसे बढ़िया मॉडल था। तो फिर भी अगर हम 20 इपॉक वाले मॉडल की चर्चा करें तो यहाँ पर हमारा अब अच्छा स्कोर आया। अभी हम स्कोर भी पता लगाएंगे, पहले हम ये जान ले जो हमारा डाटा था, फुल डाटा सेट था, उसमें सबसे स्टार्टिंग डेट क्या थी। स्टार्टिंग डेट थी हमारी 9 सितंबर 2015, और एंड डेट क्या थी हमारे फुल डाटा में, मतलब कि 9 सितंबर 2015 से 25 जुलाई 2025 तक का डाटा था ये। तो हमने अब यहाँ पर हम क्या करेंगे, जो हमने मॉडल किया उस मॉडल पर हम प्रिडिक्ट करेंगे 20% ऑफ डाटा को, जो हमने फीड नहीं किया था उसके अंदर, उस 20% डाटा को ऊपर हम प्रिडिक्शन करेंगे। जो ये 20% डाटा पता नहीं है कंप्यूटर को कि क्या है, वो अनजान है उससे। The computer does not know what is the 20% data, so it is predicting on this 20% data now. So it does not know that 20% data, now it is predicting on that 20% of the data. So it predicts here now. It is doing prediction. Prediction is done. Now let's see what is the shape, rows and columns numbers in this prediction. See, these are the predictions. Now we can see in our y test, we can see in our y test there was this much rows and this much columns. So we put this much rows and this much column, 1,90,61 rows in this trained model, and it is predicted, it has done the same number of predictions. It is obviously it will do same number of predictions. So this is our prediction dataset shape. Now let's say our y-test shape was also this same. The shape is same, but this is predicted data and this is test data. So let's see. Let's see what is our predicted value. Our predicted values are, these are our predicted values. These are our predicted values. Now let's say what is our test values. These are test values. Our actual value is 18728.7 at first record, and here it is 186.783 in predicted. So very low error is there when we subtract this predicted value from this actual value. Very low error is similarly different errors will come for all these single values. Now what we do, now we will evaluate this model. For evaluating this model, we first check how much is the good fit. The fit is approximately 99.5% fit is there. Now let's import accuracy score also. Now let's check accuracy. How accurate is the model prediction? Let's check accuracy score. Now let's check accuracy score. How good accurate is the model? Let's write here accuracy. How accurate is our model? How accurate is the prediction? How accurate is the prediction? Now let's check that. Why it is not? Oh no, not accuracy score. I have done wrong. This is for classification. We will use mean MAE. Let's check the mean absolute error. Now let's check how well good prediction is our model. Now let's check mean absolute error. Mean absolute error. Now let's copy this. We calculate the this mean absolute error will tell how good prediction is our model. How good well our model has predicted the prices. This mean absolute error will tell. Let's see our mean absolute error is, we can delete this, or we can write here R2 score. R2 score. R2 score is 99.5% from 100%, and mean absolute error is 124. This there is only error of 124 rupees when we sum up all the errors. So it tells that in 9,75,000 prices, when we sum up all the errors, the error comes to 124 rupees. So this error is quite low for 9,75,000 of rows. This error is quite low. So that is it. Now let's say Nifty date.ilog time. Okay. So our model was from our trained model was from 1 September 9 September 9 September 2020 2015 9 September 2015 to 3 February 2023, and from this is our date of training data set, and from 4 February 2025 2020 or 4 February 2023 to 27 July 2025 was our test dataset date. This is 20%, and that was train was 80%. So that is it in this video. We get very good prediction score, and very good fitting score, greater than 99%. In some cases, when in poor models, this fitting score comes in negative, even in -1000%, -500% in poor models, or in average models the fitting score comes around 60 to 70%. But in very good model, this is uh, exceptionally very good, 99.5% score. This tells us that this Nifty minute level data is very predictable and can be utilized in trading, algo trading. It can be utilized in this model, because the fitting score is good, and the mean absolute error is quite also good. So when we do algo trading with this LSTM model that I have trained, there will be plus minus 124 rupees of error in our trading models. So for that we can, what we can do, we can we can consider that whatever price we are setting for buying or selling, there can be minus 124 actual price that it will go, or plus 124 actual price it will go. So for that, we can evaluate the mathematical model accordingly. But the purpose of this video was to show that the Nifty data is very predictable. The minute level data, 1 minute, 2 minute, 3 minute, is very highly predictable, because the score is very good and fitting is very good. So that was for this video. Thank you so much. Have a great day.